Great. All right, let me move through this then. Um, so real quick, I just want to talk about my employer. I'm going to mention them one time and then not any other time, but they're paying for me to do this. So Fusion Auth is something like Firebase or Firestore. No, Firebase. It's a user data store, so it doesn't do all kinds of data. It does just user authentication stuff. It has it's free as in beer, supports a number of different technologies, and the reason why it's material for this presentation is we produce a lot of JWTs or JOTs. About me, who cares? You didn't come here to learn about Dan Moore. You came here to learn about JWTs. This is my question slide. Again, feel free to ask a question with your voice or in chat. And as we already saw earlier, my internet connection is, I think it should be more stable now. I kind of shifted things around, but if I do lag, please just kind of go ahead and put a note in the chat and I can go back to that slide and review it. So JWTs briefly, it's a JSON web token. It's actually pronounced JOT, which was news to me when I kind of started learning about them, but it's a standard from the IETF 7519. And really what they are is stateless, portable identifiers. So you can basically encode a JSON object, you sign it so that you know that it hasn't been changed, and then you turn it into base64, and then you can send it in headers, you can send it in forum posts, you can send it as query strings, although you probably shouldn't. And it's really great for APIs because you can have an identity provider generate this JOT and hand it to a client, and that client can present it to various different APIs who can decode it, examine it, and determine what level of access this holder of this JOT is allowed. It's a base64 encoded string. So let's just kind of walk through this scenario. So we have a typical kind of microservices application here. We have a user API and a to-do API. We have these clients over on the left. And the user API looks like this, nothing crazy, just a normal user database. The to-do API has to-dos in it. And that to-do table might look a little bit like this. You have to have some kind of identifier, you have the text of the to-do, and then you have the user ID, which references which users to-dos are recorded. If you are building a mobile application, you might have that post to the login endpoint, which would then go against the user API, and that data would be retrieved from the users table, and then we would send back JSON, right? And so then the JSON might look a little bit something like this, right? Has identifier, has my name, what roles I have. And then to get my to-dos, the client would then pass that user ID up to the to-do API. And then the to-do API would go against the to-dos database, pull that back, whatever to-dos I had, and then send back JSON. And then the client could render that. The issue with that, of course, is that you can, a malicious client might look at the network traffic and say, oh, they're just passing user ID. I wonder what user ID one, what their to-dos are. And so you can basically iterate that ID because it's a reasonable identifier. And obviously that's not a great idea. Some things are really, really important. And the fact that I don't want anyone to know that I have a task of going to get milk from the store, for example. That's important to keep secret. So what you can do is kind of take the next level up, right? Which is you have the user API generate this opaque token. That opaque token gets handed to the client. The client then presents that to the to-do API. And then the to-do API gets this token. Well, it can't look that up necessarily. It doesn't really know what that is, but it can pass that token back to the user API and get back the user's JSON. And then go ahead and use the user ID or whatever other identifier for the user is to pull the data out of the to-do database or data store. Makes total sense. Has a couple of problems. So basically you need to maintain this user token mapping. The user API needs to kind of keep track of those, and it's chatty and it couples the user API to everything, right? Anything that gets this token now needs to talk to the user API. Now, when you only have 2 services, not that big a deal. But if you have 20 or 30, then everything needs to talk to the user API, and you need to make sure that you can scale that it's available all the time. The next iteration is to use a JWT, a JSON Web Token. And so in this case, the user API generates the JWT and passes it to the client. The client, again, it might as well be opaque to the client. They can look at them and decode them. And we'll talk about some of the security ramifications of that later, but they don't have to. They can present that to the To-Do API. And now the To-Do API can actually look at that JWT. Because it's signed, it knows that it came from the user API, so it hasn't been changed over the wire, which obviously is a huge security risk. And it can look at that user ID, it can look at the roles of that user without ever talking to the user API. So that really is the reason for JWTs to exist. That's why they're useful, is they decouple the identity from they decouple who consumes the identity from who generates the identity. The other nice thing that you can do is you can actually sign them with a public-private key pair. And so in that case, you can verify that the user API generated this JWT without sharing any secrets with them. And we'll kind of see how that would work in a couple of slides. The one thing that's worth driving home is that you don't want to put any secrets in your JWT. So you don't want to put any secrets in it. The JWTs are cryptographically signed typically, but they're not encrypted. So that means that anybody with a JWT who happens to, whether that's a malicious client, someone who's man in the middle attacking you, something where a JWT gets put into a browser cache or something like that, anyone who gets that can decode everything in there. So that's why I think it's a really good idea to put only kind of public-ish information in there, and you wouldn't want to put any secrets in a JWT. But you can put an ID, and then later you can pull things out by that ID. So here is a JWT in all its glory, and they have 3 different clauses. There's a header, which is that light green, the payload, which is the blue, and the signature, which is the tan. And we're going to look at each of those in turn. So the JWT header it can specify the algorithm that was used to sign the JWT. It can specify that it's a type of JWT. It can specify a key identifier. There's a couple of other things that can be put in there. And it's, again, this is just URL encoded, JSON. The payload is slightly more interesting. This is, again, a JSON object. You can put whatever the heck you want in there. And there's a couple of different kinds of claims. Some are standardized, some are in the specification. And IS is one of those, and this is basically the issuer of the JWT. So that's some identifier of the user API in the diagram that we've seen in the past. There's an expiration time, which is just the epoch seconds. And then there's an audience, which is who this JWT was created for, who's supposed to consume this JWT. And there's a sub claim, which is basically the subscriber or the person or thing that this JWT is about, that this JWT is describing. And so those are all claims that you should really look at as a consumer to verify that this JWT is who you expect it to be for. Because remember, the consumer is what's looking at this JWT and then verifying whether or not they're allowed, the person or the entity presenting this JWT is allowed access. The signature is basically just a cryptographic signature. It's encoded of the payload and the header. So when the JWT is presented to the To-Do API, it can decode that JWT and it can see the subscriber ID, and then it can do a select star against the database from the to-dos where that user ID is presented. That's the end kind of goal of all this. So a couple of interesting hacks around JWTs. You actually don't have to sign them, and that's a bad idea in general. There are a lot of different options and a lot of different ways to can kind of assemble them. And then again, it can contain a JSON object, but you shouldn't put anything there that you wouldn't want someone who gets the JWT whether that's, again, a malicious client or somebody else, to be able to see. So here's a little bit more in depth about dropping the signature. So you can get rid of that red part, which is the signature, and that turns the JWT into this. And again, the header is still there, but it changes the algorithm. Making this particular choice changes the algorithm to none. And the payload stays the same. So whenever you see a JWT that has that's missing that third clause, that's what you're seeing as algorithm none. So the specification allows this, and the short answer for that is that you just don't ever allow it. And you as a consumer should actually, if you see a JWT signed with algorithm none, that means that you don't have any guarantees that someone didn't just create it, or some other system didn't just generate this JWT, and then you can't really trust the payload, right? Because the payload could be adjusted very easily. Now, there's always a depends. I'm a former consultant, and so if you have some other way to verify a JWT is unchanged, whether that's RFC 8705, mutual TLS, whether you're all over VPN, whether your clients are all isolated on a private network, then you could use a JWT, especially if you're really concerned about performance and you've benchmarked that. You can use, as I had mentioned earlier, public and private keys. The JWT I showed you earlier was actually signed with a symmetric key, the HMAC algorithm. If you want to use public-private, the nice thing about that is that this user API can sign their JWT with a private key, and the to API can actually pull the public key from the user API, and then can verify that that user API did sign this key. And I've seen it with RSA, I've seen it with elliptic cryptography. So you have a variety of algorithms to choose from. That's really great if you actually are in a big organization or possibly cross-organization. And this user API is managed by one set of people, and they don't really trust or have the ability to share a secret with the people who write the to-do API. Then using public-private key pairs lets you get around that. So this is what it would look like. And if you have multiple keys, you can actually specify in the JWT header, the key ID that it can then, again, this is just at a well-known endpoint, you can have a list of the public keys. So the resource server, the to-do API in this scenario actually pull the key that was used to sign the JWT. It'd also be useful if you were rotating keys as well. Real quick, kind of how to choose the signing algorithm. You want to think about how many different systems you're going to use. You want to think about, can you share secrets? Can you trust the secret to other systems? If that to-do API and the user API are both using a symmetric algorithm to verify the signature, then the to-do API has the same secret as the user API, which means that the to-do API can actually generate a signed JWT that would look just the same as if the user API generated that. That may or may not be an issue depending on how your system is structured organizationally. You want to think about rotation of keys. It's easy to rotate public keys, and then performance. Symmetric keys are faster than public-private keys. Refresh tokens are an important part of JWTs. JWTs are supposed to be short-lived, and refresh tokens are longer-lived and basically can be used to mint new JWTs. So in this case, we would have the user API would hand down both a JWT and a refresh token to the client, and then when the client would pass the JWT to to-do API repeatedly until it received a message from the to-do API saying, hey, this JWT is no longer valid, in which case it would catch that, and then would pass the refresh token back to the user API, which could then mint a new JWT. Pass that to the client then presents this to the to-do API. And that's a way for you to keep JWTs short-lived, but still not require your user to authenticate regularly. If you're deleting users, you might use something like this in a normal, kind of monolith, but you don't have on-delete cascade when you're building a distributed system. So you have a couple options here. One is you can push the complexity to the client, which I'm not typically a fan of, doesn't scale very well. Or you can push the complexity to the server side. And what you can do is you can have any API that's interested in hearing about a user being deleted, right? So that they can delete the to-dos or clean up when someone basically uninstalls an application or deletes their account. Those APIs can register and receive an event that, hey, this user's been deleted. And then the client just has to fire one delete event, and everyone else is responsible for cleaning up after themselves. Log out, you want to basically refresh the revoke the refresh token. You don't really have a great way to revoke JWTs, and we'll talk a little bit more about that later. When a logout happens, the client should remove the refresh token, remove the JWT. The user API marks that refresh token as being invalid. So if someone else presents that refresh token, they're not going to get a new JWT. But there's a JWT kind of floating around here that someone else could have intercepted. Again, if you want to log everyone out, make sure you revoke all the refresh tokens. Or if you want to log one person out, you've kind of given them multiple refresh tokens, you want to revoke all of those. So can you revoke JWTs? Well, sort of. If a user account's been breached, that's typically a bad thing. You have a couple of options here. The first is you can wait it out, because all JWTs should have a short expiration time. And depending on the severity of the breach, like who the user is, what your comfort level is, you may just want to wait for 5 or 10 or 20 minutes whenever the JWTs expire. That's probably the least secure option, but it could be a valid option. You can rotate your keys, which depending on how many keys you signed or how many JWTs you signed that key with, could log everyone out, right? Or it could log just a portion of people out. So that's kind of the light it on fire kind of option. You also have this time window solution, which basically pushes some state into the various consumers of the JWTs. I'm going to kind of scoot through this pretty quick because I don't have a ton of time. But in this case, you in addition to registering for delete events, you register for log out events essentially. And then the to-do API can keep track of who has logged out. And if that JWT is presented to them for a subscriber who is logged out, they can refuse it. So again, it kind of defeats some of the purpose of JWTs because it makes it more stateful, but it gives you that tighter window of possible unauthorized access. So I'm going to skip through this. I'm going to skip code because I have 2 minutes left. So as far as JWTs and JavaScript, I think you want to think about what are you trying to accomplish. If you're generating and parsing JWTs, then there's a great JSON web token package. And then if you're thinking about authorization, I have not delved deeply into this. I Googled a little bit, and there are some pieces of middleware out there that will look at a JWT and examine it and see if it's valid, and then basically do authentication based on that, or authorization, excuse me. Here's some tools. Here's a debugger that you can actually cut and paste my JWT from my slides into and see what it looks like. There's a code I didn't have time to go over, and then I wrote a post, an article about how to build a secure JWT from the identity provider perspective, from the consumer perspective, from the client perspective. So that would be worth looking at. And then thank you. Thanks for having me. If you want to contact me, or I'm happy to chat over email about authentication systems, Fusion Auth, or JWTs.
Awesome. Thanks so much, Dan. That was awesome. Anyone have any questions? Dan, do you mind just dropping some contact info in the chat for anyone that wants to get in touch with you after?
For sure, I'll do that.
Hi, Dan. It was a nice demo. I have one question. By the way, my name is Sriram. This is the first time I was joining in this meeting. The question is like, I was building one app. So I'm using JWT, and my backend is Node.js and frontend is React.js. I was in a bit of confusion, like the way how I implemented JWT is I'm attaching to the cookies rather than putting into the local storage because I want to suppress the headers. So which one is the best practice, like putting it in local storage or putting it to the cookie and make it as HTTPS? Because sometimes while I'm closing the window, local storage is in some browsers is not clearing up. So what would be your suggestion on that?
Yeah, that's a great question. So, basically it sounds to me like a meta question is, where do you securely store a JWT on a client, on JavaScript client in a browser? And local storage, I would not use that because that's really open to everybody. I think an HTTP cookie or a cookie is still, unless it's set to HTTP only, it is accessible to any thing that's running in the browser, right? Like that's running on that page. So, it really does depend on how secure you want things to be. But our recommendation actually is never put the JWT in the browser at all, right? Have that node middleware hold the JWT, and then use the session to kind of connect the client to the JWT. Now that doesn't always work, and so our second, the second best solution is a secure HTTP only cookie. That means that you're not going to be able to reach it with JavaScript, which means you won't be able to push it into a header with fetch or something like that. But you just have to think about the security ramifications of somebody else getting your access token. And again, that goes back to that time window solution or those options. Like, what would happen if an arbitrary piece of JavaScript from an attacker got your JWT? Like, would it be a horrible thing? Would it be like, it's okay, it's just dog pictures or whatever? You need to make that kind of security decision, but those are our recommendations. Does that help?
Yeah, that's okay. Yeah, that's good. Thank you.
Yeah, thank you.